Hello, this is Mark Vianello, the inventor and developer of the VFC DLOM calculator. In this segment, I will demonstrate the double probability DLOM calculator. I'm already logged in, but you will need to register and have an active subscription to make any calculations. First, let's select our calculator. We do that by hovering our cursor over the Calculators tab in the horizontal navigation, and for this example, select Double Probability DLOM Calculator. Step 1 involves creating or selecting a report profile. I will choose one that I previously created for Can Build Construction Company. Pay attention to the valuation date. The VFC DLOM calculator uses the valuation date in its price volatility functions. For this example, my valuation date is December 31, 2010. Step 2 involves defining the marketing period probabilities. Choosing the first radio button provides a DLOM based on the probabilities calculated by VFC from the entire population of private sale transactions reported by BizComps. Choosing the second radio button provides a DLOM using probabilities calculated by VFC from subsets of the BizComps database. We'll come back to that button in a moment. Choosing the third radio button allows the user to enter probability metrics from alternative sources, which could even represent sales of assets other than privately held businesses. If you use this option, simply provide a name for each of the metrics that you enter and its associated mean and standard deviation. Now let's return to the second radio button. This screen allows users to select one or more subsets of data to craft a marketing period that is more representative of the valuation subject than the entire population of private sale transactions reported by BizComps might be. In the right half of the screen, you see something we call the precision engine. This feature allows users to quickly see the effects on probability distribution of their choices of different subsets. Note that the population and each subset will always have an initial precision value of 100. Can Build is in the construction business, so I will make that SIC code selection. The marketing period probability distribution of construction businesses in the BizComps database currently has a precision factor of about 102. This is a tighter distribution than the entire BizComps population. Keep in mind that precision factors change as sale transactions are added to the BizComps database and VFC updates its marketing period metrics. Can Build is located in Missouri, so I will make that selection. The marketing period probability distribution of businesses sold in Missouri currently has a precision factor of about 95, which is more dispersed than the entire BizComps population. Our valuation date is in 2010, so I will make that selection. The marketing period probability distribution of businesses listed for sale in 2010 currently has a precision factor of about 117. This is much tighter than the entire BizComps population. Our valuation month is December, so I will make that selection. The marketing period probability distribution of businesses listed for sale in December currently has a precision factor of about 94. At VFC, we equate the asking prices of businesses in the transactional databases with marketable equivalent value. I have not calculated that value for Can Build, so I will skip that selection. Can Build has 8 employees, so I will make that selection. The marketing probability distribution of businesses with 6 to 10 employees currently has a precision factor of about 104. And Can Build has annual revenues over $2.7 million, so I will make that selection. The marketing probability distribution of businesses with more than $2.7 million of annual revenues currently has a precision factor of about 113. The precision engine then informs us that our selections have a cumulative precision value of about 104, which is 4% more precise than the total population of BizCom's transactions. Step 3 involves defining the price volatility probabilities. Choosing the first radio button allows users to enter specific price volatility assumptions. Choosing the second radio button allows users to enter the ticker symbols of publicly traded stocks and stock indices to use as guidelines for price volatility assumptions. CanBuild competes in the international market, so I will enter the ticker symbols of several small international construction companies for this example. Be sure to separate the ticker symbols with commas. The VFC DLOM calculator will obtain the price history of the specified ticker symbols and compute their price volatilities for the 50, 100, 250, and 500 trading days prior to the valuation date, which in this case, of course, is December 31, 2010. Or users can enter a specific date range. I will select the 500-day radio button for this example. Now let's click the Run Report button. We now see a screen report of the results for a double probability DLOM. On the left side of the screen is a section that summarizes various DLOM measurement points. We see that the full probability adjusted DLOM is 16.0%. DLOM measured at the marketing period mean is 8.8%. DLOM measured at the median of the probability distribution is 6.7%. And the DLOM measured at the mode of the marketing period probability distribution is 3%. We can also look at DLOM based on price volatility measurements. Here we see that DLOM measured at the price volatility mean is 6.5%. DLOM measured at the price volatility median is 4.0%. And DLOM measured at the price volatility mode is 1.1%. The next section on the left provides marketing period statistics. The average marketing period that we have crafted is 225 days. There's a standard deviation of 171 days. We learned that CanBuild has a 50% probability of selling within 179 days, and that the peak period of sale expectation occurs at 113 days. We also learned that there's a 5% chance that CanBuild will sell in a time period that is greater than 543 days. CanBuild has a probability adjusted marketing period of 197 days. And the third section on the left side provides price volatility statistics. The mean price volatility is 31.1% with a standard deviation of the same. The median price volatility is 22%. The most frequent price volatility is 11%. And there's a 5% probability that price volatility would be greater than 86.4%. Now let's look at the right-hand side of the report. At the top are 15 graphs. These graphs can be dragged and dropped into your report. They are also expandable. This particular graph shows the probability distribution of price volatility in red and marketing period probability in blue. The second graph shows the combined probability in 3D. This graph is instructive because it shows that the more extreme combinations of marketing period probability and price volatility have a very low probability of occurrence and therefore have little influence on the ultimate DLOM calculation. The third graph is an interesting one. It shows a bit of red in the right-hand corner. This graph is a two-dimensional matrix of each combination of price volatility and marketing period probability. The area in green indicates that raw DLOM, which is the value that would result by application of the Longstaff method for the specific combination of price volatility and marketing period probability, is not greater than 100%. But there's an area in the upper right that's red. That area indicates the combinations of price volatility and marketing period probability that resulted in raw DLOM greater than 100%. The VFC DLOM calculator automatically limits such combinations to a 100% maximum DLOM. The fourth graph is a three-dimensional view of the third graph and shows in red the area of price volatility and marketing period probability combination that results in a raw DLOM greater than 100%. The fifth graph presents the cumulative buildup of probability-adjusted DLOM measured at the mean price volatility and compares it to raw DLOM that would be calculated at the mean price volatility for individual static marketing period days. The VFC DLOM calculator provides a similar graph measured at the median of price volatility and at the mode of price volatility. The eighth graph compares cumulative DLOM measured at the mode, median, and mean of price volatility in comparison to full probability adjusted DLOM. The next set of four graphs are similar to what we just saw, but instead of being measured at the mean, median, and mode of price volatility, it's measured at the mean, median, and mode of marketing period days. And again, there is a comparison of cumulative DLOM. The next graph presents a probability distribution of DLOM calculated separately for price volatility and marketing period. The 14th graph is a 3D image of the distribution of probability-adjusted DLOM. And the 15th graph is a 3D image of the cumulative buildup of probability-adjusted DLOM.